Today we're going to discuss rationalizing the denominator. And so you want to make a note that there should never be a radical in the denominator of your final answer. So now we're going to do some examples. And our first example is starting with 2 over the square root of 3. So if we have 2 over the square root of 3, we want to notice that we have a radical in our denominator here, and we noted above that we should never have a radical in the denominator of our final answer. So to get rid of this radical, what we're going to do is we're going to multiply by a fraction of that radical over itself. And the reason that we can do that is because anything divided by itself like this is equal to 1. And if we were to take a number like 2 over the square root of 3 and multiply it by 1, we would get the same value as 2 over the square root of 3. So when we do this, we're going to do the numerator times the numerator. So 2 times the square root of 3 gives us 2 times the square root of 3 over denominator times denominator. So we'd get square root of 3 times the square root of 3, which is the square root of 3 squared. And then the square cancels with the square root. And so we get 2 times the square root of 3 over 3 as our final answer. And then if we look at this denominator closer, the reason the squared can cancel with the square root is because if we were to take the square root of 3 times the square root of 3, that would give us the square root of 9, and the square root of 9 is 3. Example 2. If we have 1 over 2 times the square root of 3, we're going to look at our radical that's in the denominator, and we're going to multiply by just the radical over the radical. And so when we do that, we're going to do numerator times numerator. So 1 times the square root of 3 is the square root of 3 over 2 square root of 3 times the square root of 3 is going to be 2 times the square root of 3 squared. And so that squared will cancel with the square root for the same reason as in example 1. And so that gives us the square root of 3 over 2 times 3, which is the square root of 3 over 6. Example 3, if we have 2 over 3 square root of 2, the square root of 2 is our radical. So we're going to multiply our fraction by the square root of 2 over the square root of 2. Now we multiply numerator by numerator, so 2 times the square root of 2 over denominator times denominator, so 3 times the square root of 2 squared. And that squared cancels with the square root. And so that gives us 2 times the square root of 2 over 3 times 2. And now we can reduce this 2 over 2 to give us 1 over 1. And so 1 times the square root of 2 is the square root of 2, and 3 times 1 is 3. So square root of 2 over 3 is our final answer. Now we're going to look at simplifying the radical. And so an example of this, if I were to give you the square root of 180, we're going to prime factor tree 180. So if we take two factors of 180, like 60 and 3, and 3 here is a prime number, so I'm going to highlight it or circle it or something. And then factors of 60, so if we do 6 and 10, neither of those are prime, so we keep going. Factors of 6, so 3 and 2. 3 and 2 are both prime numbers. And then we have factors of 10, so 5 and 2, which are also both prime numbers. So now what we want to look at is we want pairs, and so we have a pair of 2s and we have a pair of 3s. And so if we were to, and then, we also have a 5 that's left over here. And so if we were to rewrite this, it would be the square root of 2 times 2 times 3 times 3 times 5, which would give us the square root of 2 squared times 3 squared times 5. And then we could break that up further and make it the square root of 2 squared times the square root of 3 squared times the square root of 5, which then gives us the square root of 4 times the square root of 3 times the square, not the square root of 3, square root of 9, and then times the square root of 5. And the square root of 4 is 2, times the square root of 9 is 3, times the square root of 5, which isn't a nice whole number. So then that ends up giving us 6 square root of 5 as our final answer. And we could have just gone straight from our factor to our answer, because if you notice, we have a pair of 2s and a pair of 3s, and so if we do 2 times 3, we get the 6 here. Then we're left with a 5, so if we take the square root of that 5 that doesn't have a pair.